so let's solve this problem. Okay, let us read. A nozzle 10 centimeters by 4 centimeters is discharging vertically upward at a point 30 centimeters below the tip of the nozzle. The pressure is maintained at 145 kilopascal. If the available power in the jet is 2.6 kilowatts, okay, you are to solve this. The height through which the jet will rise. So, gaano kataas yung aabutin ng jet issued from the nozzle. Then, the coefficient of velocity. The diameter of the jet, 6 meters above the tip of the nozzle. Okay. So, this is your, this is the problem, the figure. So, this is the hose. The diameter is 4 centimeters. The inlet or the hose na kung saan nakakabit yung nozzle is 10 centimeters. Okay? It discharges upward, so that is the jet issued from the from this opening or from this nozzle. Okay, so lagyan natin ng numbers. Let's mark this by numbers. Let's make this yung sa problem. Ang sabi ay at a point 30 centimeters below the tip. So this is the tip of the nozzle, 30 centimeters. Lagay natin na 0.1. The nozzle tip is 0.2. The 0.3 is the problem. The jet 6 meters above the tip of the nozzle. Ano daw yung diameter? Okay? And then number 4 is the maximum height to which the jet will rise. So yun yung problem natin. So let us solve for number 1 o letter A. Gaano kataas daw yung jet, yung aabuti ng jet that is issued from the nozzle. So let us solve. Okay? So this is very familiar na in your formula. Continuity of flow. There is continuous flow at 0.1 to 0.2. So Q1 is equal to Q2. We solve for B1 in terms of B2. And using the using our Bernoulli's equation, considering the head loss from 1 to 2, okay, the total head at 0.1 is equal to the total head at 0.2 plus the head loss occurring from 1 to 2. Now, isisiro natin yung pressure head at 2 kasi atmospheric yung pressure doon. And then, considering 0.2 as our datum, there is no elevation, so 0 din siya. So, what is left in the equation is, okay, so substitute natin yung B1 is 0.16 B2. Then, the given pressure at a point 30 centimeters below the tip is 145 over 9.81. Okay, 0.1 is below the datum, so that's negative 0.3. Okay, velocity head at 0.2, the head loss at 1 to 2. So we obtain an equation that is in terms of C sub B and B sub 2. Okay, so that is equation 1. Now recall the formula for power, the discharge, the unit weight, and the total energy. Now what is the total energy at 0.2? Okay, at 0.2, wala naman tayong total energy kasi atmospheric tsaka yun ang datum. So, the total energy at 0.2 is the velocity head. So, i-substitute natin. We solve for B sub 2. Okay, so, this will be B cube. B cube yan. So, you're going to get the cube root of this quantity and obtain B sub 2, 16.05. Then, we substitute it to equation 1. So, our C sub, so pag sinubstitute natin to equation 1, we solve for C sub B, and that is 0.94. So, let us already, we have already determined the coefficient of velocity. Now, let us answer the other question. What is the maximum height the jet will reach as it is discharged from the opening, from the nozzle opening. So we write Bernoulli's energy equation between 2 and 4. So 2 is the opening, the discharging end of the nozzle. 4 is the maximum height hanggang dito. Okay? So this is the total energy at 0.2, the total energy at 0.4. Now, siniro ko lahat ito. Okay, siniro ko lahat ito because discharging through the atmosphere and therefore atmospheric pressure. Z2 is the datum, point 2 is the datum, so there is no elevation, 0. Now, the velocity head at point 4, this is where the travel of the jet stops. Dito na nawawala yung, tapos na yung pagtaas niya, so wala nang velocity sa point 4, so 0 yan. And it's also atmospheric, so what is left in our Bernoulli's energy equation are the velocity head and the elevation head at point 4. So solving for Z4, okay, that is the height. That is the height from the discharge end 2. Solving for Z4, that is 13.13. So yun yung pinakamataas pa lang pwedeng ma-reach ng jet issued from the nozzle, 13.13 meters. Now we determine the other question requires us to determine the diameter of the jet issued from the nozzle 6 meters above the opening. So ayan. So kasi yan, di ba na napag-aralan na natin from the opening where the jet is discharged, there is contraction. There is contraction, but because of gravity, as it goes upward, it is attracted by the acceleration due to gravity, and therefore the jet that is originally contracted here is expanding, nag-expand siya. So ano na yung diameter ng jet na yan, issued from the nozzle at point 3, 6 meters above point 2. Okay, so we write Bernoulli's energy equation. Again, you now see the importance of understanding Bernoulli's energy theorem. So, writing Bernoulli's energy equation between 2 and 3. So, at point 2, we take note that the only energy producing the flow at point 2 is the velocity head. At point 3, it is the velocity head, the pressure head, and the elevation head with respect to the datum. So, P3, the pressure head at point 3 is 0 kasi atmospheric. It is surrounded by the atmosphere. So, 0 siya. Okay. Then we know P2. Okay, we previously know the velocity head at the issuing opening, 16.05. So, we solve for B3. Yun, may velocity pa at this point 3 kasi tataas pa yan eh. So, it is 11.83 meters per second. Okay, so velocity, meters per second. And applying the principle of continuity, the discharge at this point 2 is the same discharge at point 3. Alam natin ang diameters diameter ng opening ng nozzle. So, ang hindi natin alam, ano na yung diameter ng jet dito. So, A2V2 is equal to A3V3. Alam natin ang velocity at point 2, the issuing nozzle. B3, na-compute na natin as 11.83. So, A3 is 1.705 times 10 to the negative 3 square meter. That is the area of the jet, the cross-section of the jet at point 3, which we assume to be circular. So, when it is circular, okay, so the area is a circular section 1.705 times 10 to the negative 3. And that is equal to pi d squared over 4. So, you solve for the diameter. So, the diameter at point 3 of the jet is 4.65. Mas malaki doon sa diameter ng dinaanan niya because nag-uumpisa na siyang mag-expand. Okay. Okay, another flow meter for measuring flow or discharge and velocities, the pitot tube. So, described as a tube with a circular cross-section bent in the form of an L shape. Both ends are open, used by Henry Pitot for measuring velocity of fluids in open flow. So, illustrated here is the Pitot tube. Ito yon. Okay? So, it is placed in an open channel or in a pipe that the flow is considered to be open. So, makikita natin dito, these are points 1 and 2, the velocity of approach at point 1, and the velocity at point 2, meron tinatawag na stagnation point where the velocity is 0. Then, as the fluid enters this small opening, it will, because of the pressure and the velocity of the fluid that enters this opening, the height of the fluid will rise h from the surface of the fluid. So this H1 and H2 represents the pressure at point 1 and the pressure at point 2. Okay? So pag sinulat natin dito yung Bernoulli's energy equation, ang matitira na lang dito is the elevations of 1 and 2 is the same. So Z1 will cancel with C2. There is no pressure at point 2. There is no velocity at point 1. So ang matitira dun sa Bernoulli's equation ay ito. And this difference in pressure between 1 and 2 can be obtained using manometer readings. So ito yung equation ng pitot tube. Considering that the approach point 1 and the stagnation point 2 is on the same elevation. So yun ang ating equation. Okay, so let's have a sample on pitot tube. So the problem is here. So meron daw tayong pipe na merong air. Okay? Fluid flowing through the pipe is air with a unit weight of 12 newtons per cubic meter, and you are required to find the velocity of flow of air inside the pipe. So this one uses the pitot tube, which is connected to a manometer to determine difference in pressure between the point of stagnation at point 1 to point 2. So, very useful ang Bernoulli's energy equation. So, ito pa rin yun. And we arrived to the equation of the velocity head at point 2 is equal to the difference in pressure between point 1 and point 2. Now, how do we find this quantity? The manometer inserted in the pipe is very useful. So, we know how to determine this difference in pressure. Pressure at 1, tapos tubig, air ito, minus the unit weight of air, standing Y, tapos plus X, minus X, so yan ay wala na, cancelled na yan. So, minus the unit weight of, this is water ito. Water yung ating fluid gauge, gauge fluid. Minus the unit weight of water, that stands X, okay? Plus the unit weight of air, that stands 0.0875 meter plus Y. So, yun doon ang galing yun. That is equal to the pressure at this point 2. Then you simplify the equation we obtained from manometer reading. We obtained the difference in pressure between 1 and 2 as 71.44 meters of air. So, this is the value. Then we substitute it here. So, we get the value of the velocity head at point 2, 71.44. And solving for B2, it is 37.44 meters per second, which is theoretical because we obtained it using the head. Now, if the given velocity coefficient is 0.99, the actual velocity of air in the pipe is 37.06 meters per second. Thank you for watching. I hope these problems help you understand more our lessons on fluid flow.